You are living inside a massive system where absolutely everything orbits around a gigantic, blazing ball of burning nuclear fire. Welcome to Black Hole Basics. Today, we will explore the incredible solar system, zooming out from our tiny blue planet. As we leave Earth behind, the camera pulls back rapidly, revealing the true scale of our magnificent cosmic neighborhood. Immediately, the massive sun sits at the very center, holding everything together with its immensely powerful and inescapable gravitational pull forever. This gigantic star accounts for an astonishing 99.8% of the total mass in our solar system. Everything else, including all 8 planets and countless smaller objects, makes up only a tiny fraction of the remaining mass. Let us begin our incredible journey by examining the burning heart of the system, the glorious and powerful sun itself. The sun is a nearly perfect sphere of extremely hot plasma, radiating massive amounts of energy into the cold void. Deep inside its core, nuclear fusion converts hydrogen into helium, releasing the brilliant light that sustains life on our Earth. Without this constant flow of radiant solar energy, our beautiful world would quickly freeze into a dark and lifeless wasteland. Massive solar flares frequently erupt from the turbulent surface, sending dangerous streams of charged particles flying through the empty space. These powerful solar winds constantly wash over the planets, shaping their atmospheres and creating beautiful auroras near their magnetic poles. Moving away from the blazing sun, we encounter the inner solar system, home to 4 small and rocky terrestrial planets. The first and closest planet to the sun is Mercury, a small world covered entirely in deep and ancient craters. Mercury has no protective atmosphere, meaning its surface experiences the most extreme and brutal temperature changes in the solar system. During the day, the surface boils under the intense solar radiation, while nighttime temperatures drop far below the freezing point. Because it orbits so close to the sun, a single year on Mercury lasts only 88 Earth days total. Despite its close proximity to the sun, deep craters near the poles of Mercury actually contain deposits of frozen water. Leaving Mercury behind, we travel further outward to reach Venus, the second planet and the hottest world in our system. Venus is often called Earth's twin because of its similar size, but its environment is actually a terrifying, toxic hellscape. A thick atmosphere of carbon dioxide traps the solar heat, creating a massive runaway greenhouse effect that melts solid lead. Dense clouds of highly corrosive sulfuric acid completely cover the planet, reflecting sunlight and making Venus shine brightly in space. The atmospheric pressure on the surface of Venus is crushing, feeling exactly like being deep underwater in the dark ocean. Despite these harsh conditions, scientists believe that Venus may have once had vast oceans of liquid water on its surface. Now, we arrive at the third rock from the sun, beautiful home planet Earth, teeming with abundant organic life. Earth is uniquely positioned in the habitable zone, where temperatures are just right for liquid water to flow freely everywhere. Our protective atmosphere shields us from harmful cosmic radiation and regulates the global climate to support millions of living species. Earth is accompanied by a single large moon, which stabilizes our axial tilt and creates the gentle ocean tides daily. The moon is the only other celestial body that human beings have successfully visited and walked upon in human history. Looking back at Earth from space, we see a fragile blue marble floating alone in the vast darkness of space. Just beyond Earth lies Mars, the famous red planet, which has captured human imagination for many centuries of recorded history. Mars gets its distinctive red color from iron oxide, or rust, which covers its dusty surface in a thick layer. This cold and desert world features massive extinct volcanoes and deep canyons that dwarf anything found on our home planet. Olympus Mons is the largest volcano in the entire solar system, standing 3 times taller than the famous Mount Everest. Mars has a very thin atmosphere, making it impossible for liquid water to exist on the surface for very long. However, scientists have discovered massive ice caps at the Martian poles and evidence of ancient riverbeds carved by flowing water. Multiple robotic rovers currently explore the Martian surface, searching for any hidden signs of past or present microscopic alien life. Mars also has two tiny, irregularly shaped moons named Phobos and Deimos, which are likely captured asteroids from deep space. Beyond the orbit of Mars, we enter the asteroid belt, a massive ring of rocky debris circling the distant sun. This region contains millions of irregularly shaped space rocks left over from the early formation of our ancient solar system. Despite what movies show, the asteroid belt is mostly empty space, with huge distances separating individual rocks from one another. The largest object in this rocky belt is Ceres, a dwarf planet that contains a significant amount of frozen water. Jupiter, the first of the massive gas giants, acts like a gravitational shield, keeping many dangerous asteroids away from Earth. Now, we reach Jupiter, the undisputed king of the planets and the largest world in our entire incredible solar system. Jupiter is so massive that it could easily fit more than 1,000 entire Earths inside its enormous gaseous volume. This giant planet is composed mostly of hydrogen and helium, swirling in colorful bands of violent storms and high winds. The Great Red Spot is a massive, spinning storm on Jupiter that has been raging continuously for over 3 centuries. Jupiter has a remarkably strong magnetic field, which creates intense radiation zones that can easily destroy unshielded electronic spacecraft equipment. The planet is orbited by at least 95 known moons, forming a fascinating miniature planetary system of its own. The 4 largest moons discovered by Galileo are Io, Europa, Ganymede, and Callisto, each with completely unique and fascinating features. Io is the most volcanically active body we know, constantly erupting massive plumes of sulfur into the dark, empty space. Europa is covered by a thick ice shell, hiding a massive subsurface ocean that might contain simple forms of life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and has its own magnetosphere. Callisto has an ancient, heavily cratered surface, providing scientists with a perfectly preserved record of the early violent solar system. Moving further outward, we arrive at Saturn, the 6th planet, famous for its magnificent and incredibly complex system of rings. Saturn is another massive gas giant, but it is incredibly light, with an average density lower than that of water. The stunning rings are made of countless pieces of ice and rock, ranging in size from tiny dust to huge mountains. These brilliant rings reflect sunlight perfectly, making Saturn one of the most beautiful and easily recognizable objects in the sky. Saturn also boasts a massive family of moons, with over 140 discovered so far by busy astronomers. Titan, the largest moon of Saturn, is the only moon in our system with a thick and completely opaque atmosphere. On the surface of Titan, rivers and lakes of liquid methane flow freely under a hazy, orange, and alien sky. Another fascinating moon is Enceladus, a bright icy world that shoots massive geysers of water vapor into the dark space. These geysers actually supply the material for one of Saturn's outer rings, showing how dynamic this incredible planetary system is. Leaving Saturn, we journey into the freezing outer solar system, where the sunlight becomes incredibly faint and the temperatures drop. Here we find Uranus, the 7th planet, a massive ice giant with a pale blue color caused by atmospheric methane. Uranus is completely unique because it rotates on its side, rolling around the sun like a massive blue bowling ball. This extreme tilt causes incredibly long and bizarre seasons, with each pole experiencing 42 years of continuous dark winter. Uranus also has a dark and faint ring system, along with 27 known moons named after characters from Shakespeare. The atmosphere of Uranus is the coldest of any planet, with temperatures plunging to -370 degrees. Deep inside this frozen giant, scientists believe that extreme pressure might actually cause diamond rain to fall toward the core. Our next stop is Neptune, the 8th and final official planet in our vast and deeply fascinating solar system neighborhood. Neptune is a vibrant blue ice giant, slightly smaller than Uranus, but significantly more massive and incredibly dense in structure. This distant world is home to the fastest winds in the solar system, reaching supersonic speeds of over 1,000 miles. The intense blue atmosphere features massive dark storms that appear and disappear rapidly across the freezing and turbulent planetary surface. Neptune has 14 known moons, with Triton being the largest and most scientifically interesting object orbiting this distant blue world. Triton is unique because it orbits Neptune in a backward direction, suggesting it was captured from the distant Kuiper belt. This freezing moon features active geysers that spray dark nitrogen dust high into its incredibly thin and extremely cold atmosphere. Beyond Neptune, we enter the Kuiper belt, a massive ring of icy bodies orbiting the Sun in the permanent twilight. This distant region is home to Pluto, the most famous dwarf planet and a beloved object of immense public fascination. Once considered the ninth planet, Pluto was reclassified due to the discovery of many similar icy bodies in this zone. Pluto features massive mountains made of solid water ice and vast flowing glaciers composed entirely of extremely cold frozen nitrogen. It is orbited by 5 moons, with Charon being so large that the two actually orbit a shared center point. Other notable dwarf planets in the Kuiper belt include Haumea, Makemake, and Eris, each with their own unique physical characteristics. Haumea spins so incredibly fast that its shape is completely stretched out into an elongated oval, resembling a cosmic football. Eris is slightly more massive than Pluto and has a highly elliptical orbit that takes it extremely far from home. These icy bodies are considered pristine remnants from the very dawn of our solar system, preserved in a deep freeze. Far beyond the Kuiper belt lies the Oort cloud, a theoretical spherical shell of icy debris surrounding our entire system. This vast cloud is believed to be the birthplace of long-period comets that occasionally dive toward the inner planets. Comets are essentially dirty snowballs made of ice, dust, and rock that heat up as they approach the warm sun. As they warm up, they release glowing gas and dust, forming spectacular tails that can stretch for millions of miles. The Oort cloud marks the true edge of the solar system, where the sun's gravitational influence finally fades completely away. To truly understand the solar system, we must talk about the mind-boggling distances that separate these fascinating celestial bodies. Space is mostly empty nothingness, and the gaps between planets are far larger than the human mind can easily comprehend. Even light, which travels at the ultimate speed limit of the universe, takes time to cross these vast cosmic oceans. When you look at the sun, you are seeing light that left its blazing surface more than 8 minutes ago. If the sun were to suddenly disappear right now, we would not even know about it for 8 full minutes. Light from the sun takes about 43 minutes to reach Jupiter and over 4 hours to finally reach Neptune. Let us use a simple visual scale to better grasp the true immensity of our vast and wonderful solar system. Imagine that the massive sun is shrunk down to the exact size of a standard yellow tennis ball sitting here. On this tiny scale, the Earth would be nothing more than a microscopic grain of sand 26 feet away. Jupiter, the largest planet, would be the size of a small marble, located over 130 feet away. Neptune would be a tiny bead sitting nearly 800 feet away from our little yellow tennis ball sun model. And the nearest star system, Alpha Centauri, would be another tennis ball located roughly 1,400 miles away from here. This incredible emptiness highlights how isolated and precious our tiny blue world truly is within the grand cosmic arena today. Humanity has sent numerous robotic probes to explore this vast system, pushing the boundaries of our scientific and technical knowledge. The Voyager spacecraft, launched decades ago, have successfully completed their grand tour of the majestic outer gas and ice giants. These brave little machines are now traveling through interstellar space, carrying a golden record with sounds and images of Earth. They serve as silent ambassadors from humanity, drifting forever through the dark void between the distant and brilliantly shining stars. Looking at the solar system as a whole, we realize it is a perfectly balanced dance of gravity and momentum. Every planet, moon, and asteroid follows the strict laws of physics, tracing elegant elliptical paths around our massive central star. This delicate cosmic ballet has been going on for over 4.5 billion years without any major interruptions. Our solar system formed from a giant rotating cloud of interstellar gas and dust known as the original solar nebula. Gravity pulled the material together, igniting the sun at the center, while the rest flattened into a spinning planetary disk. Over millions of years, tiny dust grains collided and stuck together, slowly building up the planets we see clearly today. The intense heat of the young sun pushed lighter gases outward, leaving only heavier rocky materials in the inner regions. This explains why the inner planets are mostly solid rock, while the outer planets are massive spheres of swirling gas. Despite our extensive knowledge, the solar system still holds countless deep mysteries waiting to be uncovered by curious future generations. Scientists continue to search for a hypothetical Planet 9, a massive object thought to be hiding far beyond distant Pluto. They also study ancient asteroids to understand how water and the building blocks of life first arrived on early Earth. Every new discovery reminds us of how wonderfully complex and beautifully structured our local cosmic neighborhood truly is right now. As we zoom out even further, the brilliant sun begins to fade, blending in with billions of other distant stars. Our entire massive solar system is just one single, microscopic speck within the unimaginable vastness of the Milky Way galaxy. The Milky Way itself contains hundreds of billions of stars, many of which host their own unique and fascinating planets. We are located on one of the spiral arms of this galaxy, slowly orbiting the supermassive black hole hidden inside. It takes our solar system about 250 million years to complete just one single orbit around it. This means the last time Earth was in this exact galactic position, dinosaurs were just beginning to roam the land. Looking out into the dark night sky, every single star you can see belongs to our local Milky Way neighborhood. And yet, the Milky Way is only one of an estimated 2 trillion galaxies scattered throughout the observable infinite universe. Each of these distant galaxies contains countless billions of stars and planetary systems, holding infinite possibilities for unknown alien worlds. The sheer scale of the cosmos is incredibly humbling, making our daily human struggles seem entirely insignificant in the end. But it also makes our existence incredibly special, as we are the universe experiencing and trying to understand itself consciously. From the blazing solar core to the freezing Oort cloud, our solar system is a brilliant masterpiece of natural physics. We have only just begun to scratch the surface of what lies hidden in the dark depths of deep space. If our massive solar system is just a tiny dot, then exactly how big is the rest of the universe? Thank you for exploring with us. Please subscribe to Black Hole Basics for more incredible journeys through the magnificent cosmos.